This is a conservation of momentum example, train cars. So here's the problem we're going to be working with. 3 identical connected train cars going 5 meters per second are rolling down the track when they collide with and connect to a 4th train car, which was initially at rest. What is the speed of the resulting 4-car train? So I recognize that this is a conservation of momentum problem. The rail cars riding along the train track are isolated system, and so immediately before the collision, the amount of momentum that the total 4 cars have will be equal to the total of momentum after the collision for the 4 cars. This problem is also an example of a type of collision called an inelastic collision. This is where 2 or more objects collide together and stick and then move after the collision as though they were one object. So I've gone ahead and made a sketch. There's a sketch of what's going on before the collision and after the collision. So before the collision, I have the 3 train cars moving together at 5 meters per second. And before the collision, there's a 4th train car that's sitting at rest, 0 meters per second. After the collision, there are 4 train cars all moving together with the same V final. The problem doesn't tell me the masses, but the only way I can solve this is to assume that they're probably all the same. And so I've marked their masses. There's 3m over here before, plus another m, and in the end, 4m. So again, conservation of momentum, I'm going to set P initial equal to P final. So the initial momentum is equal to the final momentum. So let's write out what that is. The initial momentum, the first object is here, and its momentum is the mass, 3m, times the velocity, which is 5 meters per second. Add to that, we have to consider all the masses in the system. Here's my other mass in this system, and that's just 1m times 0, which we probably could have left out, but I just wanted to be clear. And then finally, we have really just one object with a total mass of 4m and then a V final. So the stationary car, that momentum just turns into 0. And then I'm going to multiply the 3 and the 5. So I'll have a total of 15 times m is equal to 4m times V final. Oh, and I should add some units over here on the left-hand side. These should be meters per second. Now the m's on each side, we can divide by an m on each side. Those will cancel out. And so as my final step, I divide the 15 by 4, and I find V final is equal to 3.75 meters per second. Now, as far as whether or not this makes sense, it is less than the initial speed, which was 5 meters per second. And I was anticipating that. When you stick together with a train car that's not moving at all, then you have to give some of your momentum to that 4th car, which means the original 3 cars have to give some up. And so this makes sense to me.